graph of potential energy against the distance between the nuclei of two approaching hydrogen atoms. By the end of the session, you must be able to 1. Interpret the graph of potential energy against the distance between the nuclei of two approaching hydrogen atoms. 2. Define bond length. 3. Define bond energy. As the two hydrogen atoms approach each other, the positively charged nuclei repel each other. The negatively charged electrons also repels each other, while the nucleus of each atom attract the electrons of the other atom. When the two hydrogen atoms are far away from each other, the net force, that is the sum total of the repulsive force and the attractive force between the two atoms, is negligible. Hence, the potential energy almost approach zero. As the hydrogen atom approaches each other, the attraction forces between the oppositely charged nuclei and the electrons and the repulsive forces between like-charged two nuclei and the like-charged two electrons starts to play its role. The net electrostatic force is of attraction as the atom approach each other. The attractive force decreases as the atom approach each other, and the repulsive force increases as the atom approaches each other. During the approach, the stronger attraction force results in a decrease in potential energy. At a specific distance between the two nuclei, the attractive force and the repulsive force are balanced, and this corresponds to the minimum potential energy the atoms can have, and it is the point where atoms are bonded together. Energy is released when the bond is formed. Hence, the molecules of hydrogen is more stable than the individual atoms. Thus, hydrogen exists as diatomic molecules, H2 in nature. When atoms are bonded together, the average distance between the nuclei is called the bond length. Hence, the bond length is defined as the average distance between the nuclei of two bonding atoms in a molecule. The strength of the bond depends on the bond length. The shorter the bond length, the stronger the bond. The number of bonds also has an effect on the bond strength. Triple bonds, that is 3 pairs of bonding electrons, are stronger than both the double bond, 2 pairs, and the single bond, a pair of bonding electrons, and double bond are stronger than single bond. That is, the greater the number of bonds between nuclei of atoms, the greater the strength of the bond. If the atoms were to get even closer than the bond length, the repulsive forces between the positively charged nuclei would become dominant. This strong repulsive overpowers the attractive force, leading to a sharp increase in potential energy. The curve rises sharply. The atoms would repel each other and move apart to avoid this high energy state. To break the bond, energy is needed. The minimum energy required to break the bond is called the bond energy. In the case of helium, minimum energy required to form a bond is very close to zero. Atoms can come together and move apart very easily. Atoms never stick together. Minimum energy never low enough for atoms to stick together. Outermost energy level has maximum number of electrons, therefore no bond formation. As a result, helium cannot appear as He2. but as a single atom, He, in nature.